In this lesson, we are going to discuss integer exponents. This is working out of section 5.2 in your textbook on page 427. We are going to do numbers 2 through 82 even. So on number 2, we have the problem 3 to the negative third power. Integer exponents are when you have positive and negative exponents, including 0 for your exponents. So whenever you have a negative exponent, the way to make it positive would be to move it to the other side of the fraction. So in fractions, you always have a numerator, which is the number on top, and a denominator, which is a number on the bottom. So we would make this 3 a fraction just by drawing this division sign here, and we are going to circle the base of 3 and the negative exponent, which is negative 3, and we are going to draw an arrow as to where that 3 to the negative third is going to move. So we now have a 3 to the positive third power. The way we have a positive 3 now is once we move it from the numerator to the denominator, that exponent becomes positive. Finally, you cannot have a blank space in your numerator. You have to have some type of placeholder. If it's never written, or if it isn't written, it is always going to be a 1. So to evaluate, we will have 1 over, or 1 divided by, 3 to the third power, which is 27. Number 4, I've got x to the negative 8. So I've got a negative exponent, so I draw that line for the division. And I circle the base that has the negative exponent attached to it. And then I draw my arrow as to where it's going to go. So I have an x to the 8 in my numerator, or I'm sorry, in my denominator, because the negative 8 moved it to the denominator. And once it moves, it becomes positive. And then we have an understood exponent of 1. Or numerator. Sorry guys, my words are just kind of jumbled today. So that gives me 1 over x to the 8th. Remember, we have to have this 1 because we have to have some type of placeholder up here. Number 6, I have negative 3 to the negative third power. So I'm going to circle the base and the negative exponent that's attached to it. So I now have my negative 3 to the third power in my denominator, and I have a 1 understood in my numerator. Now by moving this negative exponent to the bottom, that does not change the coefficient. That coefficient will stay negative. The only thing that this makes positive is the exponent. So notice we now have a positive 3 for our exponent. So that gives us 1 divided by negative 3 to the third power means negative 3 times negative 3 times negative 3, which is negative 27. Number 8, I have negative 2 to the negative fourth power. So this problem is just like number 6. I'm going to circle my base and my negative exponent, draw the arrow as to where it's going to go. I now have a negative 2 to a positive fourth power, because once you move the negative exponent to the denominator, it becomes positive. And I now have a 1 for my numerator, because I have to have some type of placeholder. And negative 2 to the fourth power would give us a positive 16. So our final answer is 1 over 16. On number 10, we have 3 over 4 to the negative 2 power. So remember that you have an understood exponent if it's not written. So we've got an exponent of 1 here and an exponent of 1 here. So I'm going to distribute that negative 2 into both of those exponents. So I would have 3 to the negative 2 divided by 4 to the negative 2. Well, notice now we have two exponents that are negative, so that means we're just going to have two circles. So I'm going to circle that base that's attached to the negative exponent, and I'm going to circle this base that's attached to this negative exponent. Well, the 3 to the negative 2 will move to the denominator, and the 4 to the negative 2 will then move to the numerator. It may look right now like you are switching or flipping this fraction. In this case, since everything is a negative, you are, but that is not the case for every single one of these. So that gives me a 4 squared in the numerator, because that 4 to the negative 2 moved up top, and a 3 to the negative 2 moves on the bottom, which just makes it a 3 squared. So 4 squared is 16, 3 squared is 9. Number 12, we have 4x to the negative 3. This is a very good indication as to whether we understand exactly what we're doing here. Remember, this 4 has an understood exponent of 1. So that 4 does not have a negative exponent, so it's going to stay put where it is. But this x has an understood exponent of negative 3, and that will move down to the denominator. So my 4 stayed up top, and my x to the third is now in the denominator. Notice now that you can see that it doesn't actually flip. Sometimes it just looks like it does. Number 14, I've got negative 2x to the negative 4th power. So on this problem, I can actually move this entire base and exponent down to the denominator because it's in parentheses. So I now have negative 2x to the 4th power and an understood 1 that goes in that numerator. Remember, if there's nothing written, you always have to write that 1 there. So that gives us 1 over, and then you distribute this 4 into each exponent. So that gives us negative 2 to the 4th power, and then x to the 4th power, and then negative 2 to the 4th power is 16, and you have your x to the 4th power. So our final answer is 1 over 16x to the 4th. Now moving on to number 16. Number 16 says I have negative 5x to the negative 2. Again, this 5 has an understood 1 there, or this negative 5. So that negative 5 isn't going anywhere because it has a positive exponent. Remember, these are not simplified if they have negative exponents. That's the part that makes these not simplified. So my x to the negative 2 is going to move to the other side, which is to the denominator. So I'm going to be left with negative 5 divided by x squared. Moving on to number 18, I have 1 divided by x to the negative 5th. I'm going to circle my x to the negative 5th, and I'm going to draw an arrow to the other side where it will move. So it has now moved to my numerator. There's nothing left in the denominator, so we're going to leave it just as an x to the 5th. You cannot leave it as x to the 5th over 1. That is no good. That is not fully simplified. If you leave it over 1, that would be half points off at least. Number 20 says I've got 3 over 4x to the negative 4th. So I'm going to circle my base that has the negative exponent attached to it. So that will move to the other side. My 3 and the 4 have positive exponents, so they're not going anywhere. So that leaves me with 3x to the 4th. Notice my 4 is now positive because it moved up to my numerator, and then I still have that 4 in my denominator. 3 over 4 does not simplify, so we are finished. Number 22 says that I have x to the negative 5 over y to the negative 3. Again, this problem is going to look like it flips because everything is negative, but everything is not flipping. So my x to the negative 5 moves down to my denominator and becomes a positive 5. My y to the negative 3 moves up to the numerator and now is a positive 3. Nothing will simplify, so we are finished. Number 24, I've got y to the negative 4 times y to the positive 5. I'm going to move that y to the negative 4 to the denominator, which gives me y to the 5 over y to the 4. And when you divide your bases, you subtract your exponents. So 5 minus 4 is 1. You can either write y to the first, or you could write just y. Number 26, I have w to the negative 5 times w to the third. So I'm going to circle my base with the negative exponent and draw an arrow as to where it will go. So I'm left with w to the third divided by w to the fifth. We have the same base and we are dividing them. So when you divide your bases, you subtract your exponents. So 5 minus 3 is 2, so that's a w squared, but it actually goes in the denominator because 5 is bigger than 3. Remember, it's always going to go with that bigger exponent. And we can't just leave that numerator empty, so we have to write that 1 there. Number 28, I have b to the negative 7 times b to the negative 1. So both of these numbers have negative exponents, so they're both going to move down to the other side. So that gives me b to the negative 7, b to the positive 7 and positive 1. Since we moved them down to the denominator, they are now positives. And then we have to have that placeholder of 1 in our numerator. So we have the same base. We are multiplying them, so you add your exponents. So 7 plus 1 is 8. So I have 1 over b to the 8. Moving on to number 30. I have x to the negative 4 times x to the 4th. So I'm going to circle my base with the negative exponent, draw an arrow as to where it will go. So I now have x to the 4th divided by x to the 4th. Well, whenever you divide the same base and they have the same exponent, you're going to end up with just 1. Because if we were to divide the two numbers, like 2 divided by 2, that's always going to give you 1. X divided by x will always give you 1. So x to the 4th divided by the same x to the 4th will give you a 1. Number 32, I have x to the negative 3 over x to the negative 6. So I'm going to circle my x to the negative 3 and x to the negative 6 since they are both negative in the exponent, and I'm going to move those to the other side. So my x to the negative 3 moved to the denominator and is now a positive 3. And my x to the negative 6 will move to the numerator and will now have a positive 6. So now, when you divide your bases, you subtract your exponents. So 6 minus 3 is 3. My x to the third goes up top because 6 is bigger than 3. And 6 was on the top. Number 34 says I have w to the 4th raised to the 6th power. Oh, we're used to these. This is raising a power to another power. So that means we are going to multiply that 6 and that 4, which will leave me with a w to the 24. Number 36 says I have p to the 4th times 3p to the 3rd squared. So remember that this has an understood exponent of 1 if it's not written. So I'm going to go ahead and distribute that 2 into my parentheses, every exponent in the parentheses. You cannot go ahead and combine that p to the 4th and p to the 3rd because your order of operations tells you to do your exponents before you do your multiplication. So I now have p to the 4th times 3 squared and then p to the 6th because 3 times 2 is 6. Well, then 3 squared is 9. P to the 4th times p to the 6th. When you multiply your bases, you add your exponents. So 4 plus 6 gives us p to the 10. So our final answer should be 9p to the 10. Number 38 says I've got 5y to the negative 2 times 2y times y to the 5. That y is understood to have an exponent of 1. And I'm going to go ahead and multiply the 5 times 2. Well, no, I won't do that first. I'll actually go ahead and move my negative exponent just so that's out of the way. So it's going to go down to the bottom. So I'm left with 5 times 2y times y to the 5th all over y squared. Notice that the negative 2 becomes a positive 2 because it moved to the other side. 5 times 2 gives me 10. Y to the 1st times y to the 5th is y to the 6th because when you multiply your bases you add your exponents. And then we finish up by simplifying y to the 6th divided by y squared, which would give me 10y to the 4th because 6 minus 2 gives you 4. Number 40 says I have r to the 4th squared times r squared s times s to the 3rd squared. So let's go ahead and take care of these powers of a power. So I'm going to distribute these exponents into the exponents inside of the parentheses they're right outside of. So this 2 multiplies by this 4, this 2 multiplies by this 3. So I have r to the 8th times r squared s times s. 3 times 2 is 6, so it's s to the 6th. Now we can finish up by combining our r's and s's. So that'd be r to the 10th, s to the 7, because this s is understood to be a 1, and 1 plus 6 is 7. Now we're going to turn the page in your book and look at numbers 42 through 82. For number 42, we have a very long problem. We have p squared qr squared, p squared, q to the 3rd squared, and then r squared to the 0 power. So I'm going to first distribute these exponents. So I would be left with p squared qr squared times p squared times q to the 6th. And I get q to the 6th because 3 times 2 is 6. And then r to the 0 because 2 times 0 is 0. Now I can combine all these p's, q's, and r's. So this q is understood to be a 1. So I have p to the 2 plus 2 is 4. q to the 1 plus 6 is 7. And then r to the 2 plus 0 is 2. Now for number 44, I've got x to the negative 2 to the negative third power. So I'm going to distribute my negative 3 into the negative 2, which would give me x to the positive 6. It benefited us by going ahead and distributing that negative 3 first, because had we moved the x to the negative 2 to the denominator, we would have ended up doing it again because it would have become a negative exponent again. So our answer would be x to the 6th. Number 46 is I have a to the 0, b to the negative 4th to the third power. So I'm going to distribute that 3, which would give me a to the 0, b to the negative 12. Well, this is a little trick I came up with. Anything to the first power is itself, which would mean our answer would be just a. Anything to the 0 power is 1, so our answer would be 1 there. So since I have as a to the 0 power, that gives me 1 times b to the negative 12, which is just b to the negative 12. Well, we can't have a negative exponent, so I'm going to bring that b to the negative 12 down to the denominator. So that gives me b to the positive 12. When you move it from the numerator to the denominator, it becomes positive, and you need to have an numerator, so we're going to put a 1 there. Number 48, I have p to the negative 3 q squared all to the negative 2 power. So I'm going to distribute that negative 2 into all my exponents in the parentheses. So that gives me p to the positive 6, q to the negative 4, and then I need to make that q have a positive exponent by moving it to the other side, which would give me p to the 6th over q to the 4. Number 50 says I have 3x to the negative 2, y to the negative 2 to the third power. Well, this 3 has an understood exponent of 1, and you distribute your exponent of 3 into every exponent inside of those parentheses. So that's going to give me 3 to the third power, x to the negative 6th, y to the negative 6. So 3 to the third power is 27, and all of our x to the negative 6 and y to the negative 6, since they have those negative exponents, they're going to move to the denominator. So I have x to the 6th and y to the 6th. Number 52, a to the negative 6 over b to the negative 4. So my a to the negative 6 is going to move to the denominator, and my b to the negative 4 is going to move to the numerator. So a to the negative 6 goes down here and becomes a positive 6. b to the negative 4 comes up here, which becomes a positive 4. They don't have the same basis, so you are finished. You can't simplify any further. Number 54 says I have x to the negative 3 over y squared all raised to the negative 3 power. So I'm going to distribute that negative 3 into all of my exponents, which would give me x to the positive 9, because negative 3 times negative 3 is positive 9, divided by negative 3 times positive 2 is negative 6. Now I need to bring my y to the negative 6 to the numerator, which would give me x to the 9, y to the positive 6. Remember, once you move it from the one side to the other, your exponent becomes positive. Number 56 says I have 3x to the negative 4 squared times 2x squared over x to the 6th. So I'm going to distribute this 2 into each exponent inside of those parentheses. So that's going to give me 3 squared x to the negative 8 times 2x squared divided by x to the 6th. Well, I'm going to evaluate my 3 squared, and I'm going to move my negative exponents to the other side. So 3 squared is 9. I've got the 2x squared, and then x to the 6th is in the denominator, and the x to the 8th moved down to the denominator. So now I have 9 times 2, which is 18. And I have my x squared, and you're multiplying your bases, so you add your exponents. So 6 plus 8 is 14, so that gives me x to the 14th power. Then you're dividing your bases, so when you divide your bases, you subtract your exponents. So 14 minus 2 is 12. But when you subtract 14 minus 2, you do get 12, but your 14 is the bigger number. So your x to the 12 goes where the 14 was, which is in the denominator. Number 58 says I have 5x to the negative 4 to the negative 4th power, 2x to the 3rd to the negative 5th power. So this 5 is understood to have a 1, so I'm going to distribute that negative 4 into all of my exponents. This 2 has an understood 1, so I'm going to distribute that negative 5 into all of those exponents inside of those parentheses. So that gives me 5 to the negative 4, x to the positive 16, because negative 4 times negative 4 is positive 16. And then I have my 2 to the negative 5, and then my x to the negative 15. Well, I'm going to move all of my negative exponents down to the denominator that are in my numerator. So I'm left with x to the 16 in my numerator. I've got 5 to the 4th power, 2 to the positive 5th power, and then x to the 15 power. So when you do 5 to the 4th power, that means 5 times 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is 25. And then 25 times 25, I believe, is 625, but I can't remember, so I'm going to go ahead and multiply that out the old-fashioned way. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Bring your 0 down. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. So I was correct. It is 625. So I have x to the 16 over 625 times 2 to the 5th power is 32, x to the 15. Well, x to the 16 divided by x to the 15. When you divide your bases, you subtract your exponents. So 16 minus 15 is 1. So I have an x to the first power divided by 625 times 32 would give you 20,000. And we are finished. Number 60 says I have 3x squared to the third power, x squared to the fourth power, and then just x squared. So I'm going to distribute this exponent of 3 into all of my parentheses on the inside. Sorry about that, guys. And then I'm going to distribute this 4 into my exponent inside of that set of parentheses. So I'm left with 3 to the third power, x to the sixth power, because 2 times 3 is 6, and then x to the 8th power, because 2 times 4 is 8, and then x squared. So 3 to the third power is 27, and then x to the 6th times x to the 8th times x squared. Remember, when you multiply your bases, you add the exponents. So that gives you x to the 16. We are finished. Number 62 says that I have x squared y cubed to the fourth power, and then xy cubed to the 0 power. So I'm going to distribute that 4 into all of my exponents in that parentheses, and I'm going to distribute this 0 into all of the exponents inside of this parentheses. So I'm left with x to the 8th, because 2 times 4 is 8, y to the 12th, because 3 times 4 is 12, and then x to the 0, because 1 times 0 is 0, and then y to the 0, because 3 times 0 is 0. Well, remember, anything to the 0 power is 1. If you remember this little diagram I wrote for you, anything to the 0 power is 1. So I'm left with x to the 8th, y to the 12th, times 1, which is just x to the 8th, y to the 12th. Or you could say 8 plus 0 is 8, 12 plus 0 is 12. Number 64, I have x squared, y squared, z squared, all to the 0 power. And then I have x, y squared, z, all to the second power. And then x3, y, z squared. So I'm going to distribute this 0 into all of those exponents in that set of parentheses. And then I'm going to distribute this 2 into all of the exponents inside of this set of parentheses. So I'm left with x to the 0, y to the 0, z to the 0, because anytime you multiply a number times 0, you should get a 0. And then x squared, y to the 4th, z squared, because you multiply 2 times all of these exponents. And then you're still left with the x to the 3rd, y, z squared. Well, I'm looking at all my x's. So 0 plus 2 plus 3 is x to the 5. Y's are 0 plus 4 plus 1 is y to the 5. And then 0 plus 2 plus 2 is z to the 4. Number 66, I have 2a to the 3rd squared times a to the 0 to the 5th power. So I'm going to distribute this 2 into all of these exponents and the 5 into that exponent. So I have 2 squared a to the 6th times a to the 0. Well, we know that a to the 0 is 1, so we can just not worry about that a to the 0. 2 squared is 4, and then bring down your a to the 6th. Number 68, I have 3x to the 3rd squared times 2x to the 4th to the 5th power. So I'm going to distribute this 2 into all of my exponents, and I'm going to distribute this 5 into all of those exponents. So I'm left with 3 squared x to the 6th times 2 to the 5th x to the 20. So 3 squared is 9, x to the 6th, 2 to the 5th is 32, and I have my x to the 20th. So 9 times 32 is 288, and then x to the 6 times x to the 20 is x to the 26, because 6 plus 20 is 26. Number 70, I have x to the 8th divided by y to the 6th times 2y to the 9th over x to the 3rd. Well, I'm going to go ahead and combine all of these terms in my numerators and denominators together. So that gives me 2x to the 8 y to the 9 divided by x to the 3 y to the 6th. So I can simplify my x's, bring my 2 over. X to the 8th divided by x to the 3rd is x to the 5th, and then y to the 9th divided by y to the 6th is y to the 3rd. Number 72, I'm going to need more room than that. For number 72, I have 2w to the 5th z to the 3rd over 3x to the 3y to the 9 and then I've got times x to the 5th y to the 4th over w to the 4th z to the 0 squared. So I'm going to distribute this 2 into all of those exponents inside of that set of parentheses. So I'm left with 2w to the 5th z to the 3rd over 3x to the 3 y to the 9th times x to the 10 y to the 8th over w to the 8 z to the 0. And I got this 10 because 5 times 2 is 10. I got this 8 because 4 times 2 is 8. I got this 8 because 4 times 2 is 8. And I got this 0 because 0 times 2 is 0. Now we can go ahead and combine our numerators and our denominators. So that would give me 2w to the 5th, x to the 10, y to the 8th, and z to the 3rd. I did that because I want to have all of my variables in alphabetical order. And then I have 3w to the 8th, x to the 3rd, y to the 9, and z to the 0. Now when you divide your bases, you subtract your exponents. Well, I still have a 2 over 3, and I have my w's here. Well, I've got a 5 and an 8, so 8 minus 5 is 3, and the 3 would go in the denominator because the 8 is bigger than 5. So I have a w to the third. 10 minus 3 is 7, and the x to the 7 goes on top because 10 is bigger than 3. Y to the 1 on bottom because 9 minus 8 is 1, and 9's bigger, so it's going to go where the 9 was, which is in the denominator. And then z to the third on top because 3 minus 0 is 3. Number 74, I've got negative 5, a to the negative 2, b to the negative 4, times 2, a to the 5, b to the 0. Well, negative 5 times 2 is negative 10. Actually, let's not do it that way. Let's go ahead and move our negative exponents first. Sorry about that, guys. I think this would be best not to confuse y'all. So let's restart. And we're going to move these a to the negative 2, b to the negative 4 to the bottom. So I have negative 5 times 2a to the 5th, b to the 0, divided by my a to the negative 2 becomes a squared, my b to the negative 4 becomes b to the 4th. So I'm going to multiply my negative 5 times 2 to get negative 10, a to the 5, b to the 0, divided by a squared, b to the 4th. Now I've got a's and b's both in my fraction, so I know that I can simplify further. So I have negative 10, a to the 5th divided by a squared is a to the 3rd, and the a to the 3rd goes on top because that's where your bigger number is. And then b to the 0 divided by b to the 4th gives me a b to the 4th in the denominator because 4 was bigger than 0. Number 76, I have 6x to the 3rd, y to the negative 4th over 24x to the negative 2, y to the negative 2. Before I do anything here, I'm going to go ahead and move all of my negative exponents. So I'm left with 6x to the 3rd, x squared. The 6x to the 3rd stayed on top, and then x to the negative 2 went on top because it was negative, so now it's a positive 2, and the y to the negative 2 goes on top because it was a negative exponent, and now we have a positive. Our 24 stays in the denominator, and our y to the negative 4th goes down to the bottom, which makes it a y to the positive 4. So 6 divides into 24 4 times, and I've got x to the 3rd times x squared, which is x to the 5th, because when you multiply your bases, you add your exponents, divided by, I've got my 4 in the denominator, and then y squared divided by y 4th would give me y squared in the denominator because that y to the 4th was bigger than the y squared. Number 78, I have 24, x to the negative 5, y to the negative 3, z squared over 36, x to the negative 2, y to the 3, z to the negative 2. So now I'm going to move all of my negative exponents. So my 24 stayed on top. My x to the negative 2 moved on top and became a positive 2. My z squared stayed on top, and my z to the negative 2 moved on top, so it's now a z squared as well. My 36 stayed on bottom. My x to the negative 5 moved down to the bottom, and it became a positive 5. My y to the negative 3 moved down to the bottom, so that made it a positive 3. This y to the 3 stayed on bottom, and then that's it. So now we can finish by combining these. Well, 24 and 36. 12 goes into both of those. 12 goes into 24 2 times. 12 goes into 36 3 times. So here I've got x squared divided by x to the fifth. So 5 minus 2 is 3, and that x to the 3 goes in the denominator because 5 was bigger than 2. And then y to the third times y to the third is y to the sixth, because 3 plus 3 is 6. And I've got a z to the fourth because 2 plus 2 is 4. Now number 80. Says I have x, y3, z to the negative 4 over x to the negative 3, y to the negative 2, z to the 2, all raised to the negative 2 power. So I'm going to go ahead and distribute this 2 and negative 2 into all of my exponents. Remember that x has an exponent of 1, so times every exponent on the inside. Sorry if the arrows look a little confusing, I'm just trying to show you where that negative 2 is going to go. So that gives me x to the negative 2, y to the negative 6, z to the positive 8 over x to the positive 6, y to the positive 4, z to the negative 4. And I got all of those by multiplying that negative 2 times every exponent inside of that set of parentheses. So now I'm going to move my negative exponents so that gives me z to the 8th, z to the 4th, z to the 8th stayed up top, and z to the negative 4 moved up top and became a positive 4. And then I had my x to the 6th, y to the 4th stay on the bottom, and got to put these in alphabetical order. Sorry about that, guys. My x to the 6th stayed in bottom, and my x to the negative 2 moved on bottom, and it became a positive 2. And then my y to the 4 stayed on bottom, and a y to the 6 moved to the bottom. So now z to the 8 times z to the 4 is z to the 12, because when you multiply your bases, you add your exponents. X to the 6 times x squared is x to the 8th. Y to the 4th times y to the 6th is y to the 10. Alright, the last problem, which is number 82, says I have x to the negative 3, y to the 3, over x to the negative 4y squared, all to the third power, and then times x to the negative 2, y to the negative 2, over x, y to the 4, and this is all raised to the negative 1. So the negative 1 is going to be distributed into all of my exponents inside of that set of parentheses. And this 3 will be distributed into all of the exponents inside of this parentheses. So I'm left with x to the negative 9, y to the positive 9, over x to the negative 12, y to the positive 6, and I got that by distributing this 3 into all of these exponents. And then I have x to the 2, y to the 2, over x to the negative 1, y to the negative 4, and I got that by distributing this negative 1 into all of these exponents. Now I'm going to move my negative exponents to the other side. So I'm going to be left with y to the 9, oops, didn't see that negative there for that 12. So I'm left with x to the 12, y to the 9, over x to the 9, y to the 6th. And then I've got x squared, x to the 1, y squared, y to the 4th. And I got that just by moving these two negative exponents to the top. So now I'm going to go ahead and put everything over the same fraction. So I have x to the 12, y to the 9, nope, alphabetical order, guys, x to the 12, x squared, x to the 1st, y to the 9, y squared, y to the 4th, over x to the 9, y to the 6th. So I'm going to go ahead and combine all of my terms in my numerator, all of my variables in my numerator, not terms. So x to the 12 times x squared times x to the 1 gives me x to the 15, because when you multiply these bases you add your exponents. And then I have y to the 15 because 9 plus 2 is 11, 11 plus 4 is 15, divided by x to the 9, y to the 6th. And then we finish up by, when we divide our bases, we subtract our exponents. So that gives us x to the 6th, y to the 9th in the numerator. I hope that this lesson has helped you over integer exponents. Good luck.